Recording has started. So here we go. This is the first geometry GCSE problem solving page. There were only ever 3 questions. I couldn't find anything that easy to give you, so I chose these 3 questions, which still cause some of you some problems. So here we are. First question. This caused some of you some problems straight away. It does say it's an isosceles triangle, bold, black, dark, in your face. If it's an isosceles triangle, there's 2 versions of this isosceles triangle. If that angle is 40 degrees, then the other base angle can be 40 degrees as well. Yeah, 2 of the same angle, 2 of the same length, which means the other angle at the top must be 100, remembering that the sum of the angles in a triangle, not just an isosceles one, but all triangles, all angles sum to 180 degrees. Now, what if we're going to make that 40 degree angle the angle at the top? That means I've got 140 degrees left, which means the 2 base angles going down are 70 and 70. They're the 2 different versions you can have, and there are no more, based upon being given a single 40. So it's always good to draw a little picture. I drew that there deliberately so I can see what's happening in the story, and there's 3 marks there. This presented many of you with a lot of difficulties. You couldn't decipher it. A triangle has 3 sides, a square has 4 sides, a pentagon has 5 sides. Either way, the total area of these 3 shapes come to 48 centimeter squares. It says so. This is the punchline. The areas of these shapes are in the ratio of their sides. So that means the ratio 3 to 4 to 5 will combine to give us a total area of 48 centimeters. Well, how can that be? Because 3 and 4 and 5 don't add up to 48. No, but these 12 parts, as you can see, that it's up to 12 parts. And your 12 parts come to 48 centimeter squares of area, then 1 part must come to 4 centimeter squares of area. And a good number of you stopped on 4 centimeter squares, so I just went tick tick. It's right that you get 2 marks for that. But it wants the area of the pentagon. So the pentagon has got 5 sides, so it wants 5 times 4 centimeter squares, giving us a total of 20 centimeter squares. And there's your 3 marks. Alright, so a bit of a hidden crafty question. So Choki, if you're taking notes, now's the time to do it, or else wait for the video for you to take notes when I just upload it to YouTube after this review lesson. And here's the last question. Again, it caught some of you out big time. So here we go. What have I got here? I've got a rectangle, 4 by 1, nice and easy. I'm going to make a lovely little pattern of 4 by 1s. I want the area of the shaded bit. Well, clearly this length has to be 4, so it matches that. This isn't 4 across here, it's only 2, because this height of 1 corresponds to that part, and this height of 1 also corresponds to that part, which means the remaining part within the enclosure, if you will, is only 2 centimeters tall. So we've got a 4 by 2, 8 centimeter squares, okay? Now, one of you dear people wrote down 4 times 2 times 4 times 2. You're thinking about perimeter there. I'm not working out 4 plus 2 plus 4 plus 2, perimeter 12. No, we want the area. It's just 4 times 2. And besides, if you want an area in 2 dimensions, why are you trying to multiply 4 numbers? 4 dimensions in the physical world doesn't exist. We got, we've got horizontal, we've got vertical, and we've got depth as well. Look at that. Woo, depth. Okay, so that's that. Just 4 by 2. And there's the mark for the reasoning as well. Here's the more dodgy bit. Big mistakes here, big mistakes. The reason there are big mistakes is twofold. Number 1, I agree that's 4, and that has to be 1, that has to be 4 as well, because it's still part of the same question, playing with the 4 by 1 little rectangle. But look what they've done. This rectangle and this rectangle, they snuck into the middle and they've made them touch. and they put these two little rectangles top and bottom. So from this corner to this corner here, it's not 4. It's exactly 3.5, okay? And likewise from this corner to this corner here, it's not 4, because 0.5 centimetre is gone into the shape, so the rectangles touch. If you see a diagram like that, be wise, be sensible, fully label it like I've done. So 1, 4, 3.5, 1, 3.5, 4, 1, 4, 3.5, 1, 3.5, and 4. Once you've got all that, it's quite dangerous to write down 1 plus 4 plus 3.5 plus 1 plus 3. You're going to get dizzy adding all those up without a calculator. You will get lost in translation. So this is what I recommend you do, then you won't make a mistake. I've got 4 lots of 1. Can you see them in the picture? 1, 2, 3, 4. I've got 4 lots of 4. Can you see them? 1, 2, 3, 4. I've got 4 lots of 3.5. 1, 2, 3, 4. That's quite neat, okay? I've got multiples of 4 of different numbers. Now I can work out 4 times 1 is 4, 4 times 4 is 16, 4 lots of 3.5 is 14, because 2 3.5s make 7, double up 14. And now it's easy maths. Comes to 34. So that's 20 plus 14, 34 centimetres. A nice little walk around that little T. Okay, that's all it is. Tricky, yes. Difficult, no. Just look at the shape. Although it's not been drawn accurately, the implication is they've snuck this into the middle and they've chopped that little length off to make like a half. So only 3.5 is going to stick out. All right. So that's that. Now, let me just stop the video now and then come back and talk.